Hello, Michael.
Hello?
Hello. All right, so far, let's see, we have Michael here, Max here, Eliza here, only 3 participants. Well, I'm gonna go ahead to mark the attendance. Jose, absent. Eliza, absent. So this is Eliza. Eliza's here. Eliza is here. Bailey, absent. Ether is absent. And this section, Kaida, excused. Michael is here, Max is here. Awesome. All right, let me share the notes. Unit 2. Do you guys see it?
Yes.
Okay, very good. Thank you. Last class, we were talking about solving equations that potentially have extraneous solutions, right? We covered the procedure that used to solve a rational equation. We also covered the procedure to solve a radical equation. And I want us to look at one problem solving radical equation before we move on to start solving absolute value equations. Because last class, we did not get a chance to cover a radical equation that contains 2 radicals. We ran out of time. I was talking about this problem, all right? Let me erase those stuff. Okay, question. Yeah, this question. This is an equation, square root of m plus 2 equals square root of m plus 9. This equation is a radical equation because the equation has radicals where the variable m is under the radical. And this one is special because this equation has 2 radicals. How do we solve a radical equation if it contains 2 radicals? Firstly, we isolate one of the radicals. We have 2 radicals, right? This one and this one. And this one's already isolated on the right, so we're good. We have one of the 2 radicals isolated on the right already, so we're good. And we are going to raise both sides of the equation to the power of 2. Root m plus 2 to the power of 2. Here, root m plus 9, and then to the power of 2. The reason we raise the right side to the power of 2 because the square will cancel the square root. Square will cancel the square root and release the radicand m plus 9. So on the right side, we have no radical anymore. We have m plus 9 on the right side. The left side, I'm going to process the left side on here. Root m plus 2 to the power of 2. You can use a FOIL Or you can use the formulas you learned from Foundation 2, right? The formula I'm talking about is this formula. A plus B to the power 2 equals A squared plus 2AB plus B squared. And I'm going to use that formula. This square of binomial sum equals a perfect square trinomial. So we have a root m to the power 2 plus 2 times the multiplication of the two terms in the parentheses. So 2 times root m and then plus 2 squared. And simplify square of root m. The square cancel the square root. We have m. In the middle, 2 times 2 times root m. That gives 4 root m. 2 squared is 4. So after we expand the left side, remove the parentheses, the left side of the equation, we have m plus 4 root m plus 4. All right? And then we look at the equation. We notice both sides of the equation contains the terms m. Obviously, we can get rid of m from each side, right? By subtracting m from both sides of the equation, those two terms gonna go away, all right? And then we subtract 4 from each side. We would have 4 root m equals 5. So just now, what we have done is we got rid of one of the radicals. Originally, we have 2. Now we only have 1, right? And now we're going to handle this radical. We're going to isolate the radical. We have a 4 root m equals 5 right now, and then we divide each side by 4. Cancel, cancel. We have a square root of m equals 5 over 4. And then we are going to raise each side to the power 2. That's one of the steps in the procedure, right? We raise both sides to the power 2 is to get rid of the radical on the left side. The square would cancel the square root, and that gives us m on the left side, and on the right side we have 5 over 4, and then to the power 2. Square of 5 over 4. 5 over 4 times 5 over 4 gives 25 over 16. And this is the proposed solution, all right? This is the proposed solution. We do need to check our result when the equation is a radical equation and the root number of the radicals is even. We have a square root here. Even you do not see the 2 here, it is square root, defaulted as a square root. Since 2 is even, we need to check our answer. How do we check? We're going to plug in back the original equation, okay? I'm going to erase this part. I am recording, so if you need to take notes for that part, you can just rewind the video. The original equation is square root of m plus 2 equals square root of m plus 9. Let's plug in the proposed solution we just found, which is 25 over 16. 25 over 16 plus 2 equals 25 over 16 plus 9. I'm going to write 9 as 9 over 1 because we know we're going to have an addition of 2 fractions, right? And here we want them to have the same denominator, so I'm going to multiply both top and bottom by 16. And the left side, root 25 over 16 is 5 over 4. Because 25 is 5 squared, 16 is 4 squared, and then plus 2. On the right side, let's see what is 16 times 9. 144. So 144 plus 25, that gives 169. So under the radical, after we add the 2 fractions, we have 169 over 16. And we know 169 is a perfect square. 169, square root of 169 is 13. So I have 13 over 4 because 16 is 4 squared. And the 2 here can be written as 4 over 2. Right? And 5, sorry, we need a 4. My bad. So 2 here can be written as a over 4, all right? Because a over 4 is 2. And then add 5 over 4 is 13 over 4. So the answer we got, the proposed solution, 25 over 16, satisfy the original equation. So 25 over 16 is an actual solution of the equation. Even we don't have any extraneous solutions, does not mean we wasted the effort here. We should always check, it's necessary. We must check the proposed solution when we solve a radical equation and the index, the root number of the radical is even, like a square root. We must have this step, very important. Okay, that's everything about solving radical equations. Again, very important, you must check your answer by plugging back the original equation. Next, we're going to talk about solving absolute value equations. All right, let me enter a page break. Probably need more space here. More space here. Okay, so firstly, as I noted here, we need to look at 3 basic formulas and then go over the steps for solving an absolute value equations. The 3 basic formulas. The first one, I'm going to put it here, okay? I need more space. I'm sorry. So put it here. So firstly, I'm going to give you the 3 basic type of absolute value equation. You might wonder, why did you put a 7 here? I'm just randomly pick a positive number that is convenient. If you like, you can put a 1 here, or 10 here, or 3 over 2 if you prefer a fraction. So I put a 7 here, just to random a whole number. It's pretty convenient. All right, so if we have an equation looks like this, we're looking at number 1. Star here is an expression in x. X is the unknown in the equation. If we have an equation in this form, absolute value of star equals 7, then we should be able to right away translate it to, or convert it to, star equals 7 or star equals -7. All right? So the stuff, the expression inside the absolute value is either equals 7 or equals -7. Okay, in order to help you to understand this, we are going to review the definition for absolute value, okay? Absolute value definition. Let's say A is a real number. Absolute value only for real number. A is a real number. This notation represents the absolute value of A. It is defined as the distance between A and 0 on the real number line. Okay, so this is the real number line. Let's say this is the origin 0. Let's say A is here. Then absolute value of A is defined as the distance between the number inside the absolute value and the origin. Okay, that's the definition. Since absolute value is defined as a distance, an absolute value can never be negative because the distance cannot be negative. It could be 0 distance if you don't move, like you drive. If you don't drive, you park there. The distance you drive is 0, right? Or distance is positive. Once you start to drive, the distance becomes positive. But distance can never be negative, all right? So let's say if we have absolute value of x equals 5. This time I use a different number. It's just a number, okay? I could use 7 again, or 8, or 6, or 2. I just randomly pick a number 5. So let's solve this equation. The solution or solutions of the equation is a number whose absolute value is 5. In other words, the distance between that number and the 0 is 5. Okay, the distance between 0 and that number x is 5. 1, 2, 3, 4, 5. You must know x. If x equals 5, the equation is hold, right? But have you thought about 1, 2, 3, 4, 5, -5? -5 also satisfies the equation. On the real number line, there are two different numbers whose distance away from the 0 is 5. One is 5, positive. The other is -5, negative. Both of them is 5 units away from the origin. So the distance of both 5 and -5 from 0 is 5. Does that make sense? This is very basic. If we need to solve absolute value of x equals 5, we have two solutions, not just one solution. We have two solutions. X equals 5 or x equals -5. Plus minus 5. Two solutions, both satisfy the equation. So far, so good, guys? Any response?
Yes, I'm understanding it.
Oh, okay. So feel free to ask a question if anything's not clear, all right? I know this course is a challenging course. I try my best to make it as clear as possible. Yeah, if anything's not clear, just let me know. So if you understand the part in the bubble that I just shown you, and now let's go back to number 1. If we have absolute value of star equals 7, you might wonder, what is a star? Again, star is an expression in x. It could be just x, could be more complicated, like a 2x plus 5 or x minus 7 all over 5, could be quite complicated, but it is going to be an expression in x. Okay, so if the absolute value of the expression equals 7, when we see that kind of equation, we should quickly rewrite that equation as whatever inside the absolute value, the star equals 7 or equals -7. By doing this, we removed absolute value. The absolute value is like a prison or trap. Our variable x is trapped in that prison. In order to solve the equation for x, we have to peel the skin, eventually expose the x. I have an analogy here. Solving an equation is just like peeling an onion. This is an onion. Just imagine the variable x is hidden. Variable x is hidden inside in the core of the onion. In order to expose variable x, once we isolate or expose variable x on the left side by itself, and then the number on the right side would be the solution or proposed solution, right? So that's the idea. It's really just like peeling an onion. When you're peeling on an onion, you go from outside to the inside. You cannot peel the layer that close to x first, right? You have to peel the layer from the outside, the furthest layer, and then get to inside. The idea is the same. We know variable x is trapped in the absolute value. So we should, like absolute value is a layer of skin of the onion. We have to get rid of it. How do we get rid of it? When the right side is 7 is a positive number, that's how do we get rid of it. The stuff inside the absolute value symbol is either equals 7 or -7, because both of them have absolute value positive 7. The second basic form of absolute value equation is absolute value of star equals 0. If you have that, you may quickly rewrite the equation as star equals 0, because there's only one quantity whose absolute value is 0, which is 0. There's only one quantity whose absolute value is 0. The distance between 0 and 0 is 0. That's the only one. Okay, does that make sense? What if you see something like number 3? Left side is an absolute value. Inside the absolute value, you could have x or an expression in x. On the right side, you have a negative number. For example, -7. What do, guys? I'll give you a little bit of time to look at this equation. How do you solve this equation?
Is it just r equals -7 and 7?
No. You're going to quickly make the conclusion. The equation has no solution. Okay? You're going to quickly make a conclusion. The equation has no solution because do you remember what I said earlier? Absolute value is defined as a distance. Distance cannot be negative. This equation basically is telling us the left side is a distance, the right side is -7. Some quantity whose absolute value is -7. A distance is -7. Isn't that a contradiction? Do you see that, guys?
Yeah, I see it now.
Okay, perfect. So you should be happy when you see something like that. Quickly make a conclusion. No solution. You don't even have to solve it anymore because there's no solution. No value of x would be able to satisfy this equation at all. Okay, so you will be seeing one of the 3 basic types of absolute value equations. Sometimes maybe they look more complicated than that, then don't worry. Peel the onion, peel the skins, and then you will see it will look like one of the 3 types, one of the 3 things, okay? Yeah, we have the absolute value isolated on the left side. If the right side is a positive number, you rewrite it as star equals 7 or -7. If you have the absolute value isolated on the left, right side is 0, then quickly conclude the expression inside the absolute value is 0. Or if you have absolute value is isolated on the left side, on the right side you have a negative number, then you don't have to solve it because there's no solution. Okay, all right, let's practice. The problem we have here is, let me copy it. Is 2 minus 3 absolute value 4x minus 6 finished absolute value equals -10. That's the equation we need to solve, right? Yeah, let me double check. 2 minus 3 times absolute value 4x minus 6, absolute value equals -10. Okay. One common mistake is people trying to distribute. You don't, please do not do that. You do not distribute when you have an absolute value. When you have a parenthesis, yes, you do. This is not a set of parentheses. This is a set of absolute value symbol. You do not apply distributive property. Then what do? As you can see, we only have a variable x trapped inside the absolute value, right? So we're going to peel the onion, okay? We're going to peel the onion and eventually and try to isolate the absolute value on the left side. So the furthest operation is 2, okay? So let's get rid of 2 first. I like to draw an imaginary line here. Left side, right side. And get rid of the 2 furthest operation. And 2 minus 2 is 0, right? Then we have -3 absolute value, 4x minus 6 closed absolute value equals on the right side, -10 minus 2, -12, right? And then keep peeling the onion. Right now, you wanna isolate this on the left side. So next layer is gonna peel off, get rid of the -3. So we're gonna divide each side of the equation by -3. 93 cancel 93. So we have absolute value 4x minus 6 on the left side. On the right side, negative 12 divided by 93, positive 4. Okay, guys. Do you see? We now have an equation. On the left side, we have an absolute value of an expression in x. On the right side, we have a positive 4. Which form this equation is? Number 1, number 2, and number 3. We have 3 types, right? Basic. Which type? This one or this one or this one?
Number 1.
Number 1, exactly. So we're gonna apply this formula or rule quickly to peel the absolute value off. Yeah, now's the time to peel that layer off. How do we do that? Use the formula or rule that I gave you. So we have 4x minus 6. Yes, this part is inside. The blue part is our star, right? And that part has absolute value equals 4. So that part is equals positive 4, or it equals negative 4, right? Apply the formula here, right here. And we have no absolute value symbol anymore, right? And we have 2 equations, but they are very easy to solve. Positive 6, 4x equals 10. Divided by 4, x equals 5/2. And same thing here, plus 6, 4x equals 2. Divided by 4, x equals half. Okay? And that's it. We have 2 solutions. Do we need to check our answer? You don't have to, but it's always good to do that. Okay? It's always good to do that. For the type of absolute value equation we could ever encounter, you don't have to. But in general, we should. If we have variable x on the right side and we take a square, but I'm just saying for the absolute value equations we could ever encounter, you don't have to. But again, it's always good to double check, right? And we will not take too much time. For example, we now have 5/2. So we have 5/2. So if we plug in 5/2 here times 4, we have 10. 10 minus 6 is 4. Absolute value of 4 is 4. Times -3 is -12. -12 plus 2, -10. Okay, works. It won't take too much time. And half, if we plug in half here, 4 times half is 2. 2 minus 6 is -4. Absolute value of -4 is a positive 4. Times -3 is -12. -12 plus 2, -10. Also works. Is correct. All right. So the reason you do not have to check the answer because the process we apply never change the domain of the equation. For that reason, we don't have to. But again, it's always good to double check, right? All right. So that's one absolute value equation. Let's look at the next one. This equation is absolute value 7 minus 10x. Finished absolute value plus 20 equals 10. All right. So our variable x is trapped inside the absolute value, right? We do not have other x. We do not have variable x otherwise. Only inside the absolute value. Okay, we're gonna peel the onion. Minus 20. You're gonna read out this layer. Then we have absolute value 7 minus 10x. Finished absolute value equals 10 minus 20, -10. All right, guys. Help me out here. Now we have the equation in the one of the 3 basic forms. Left side of the equation, absolute value of an expression in x. Yeah, absolute value of star, right? Right side of the equation, -10. What do you think?
Is it just no solution?
You're right, no solution. Okay, because left side is an absolute value, is a distance. Absolute value is defined as a distance, and right side is a negative number, and distance can never be negative number. So the equation in itself, you can tell now, is a contradiction. So no solution. All right, there's no solution. Okay, next. Do you see the idea? Do you see the idea when we solve an equation? It really just like peeling an onion. Okay. So that would be everything from section 2.3. Today we're scheduled to cover 2.4. Let me check the title of 2.4. 2.4 is about linear and absolute value inequalities. Yeah. So 2.4, we are going to solve inequalities. All right. Mainly linear inequalities, very simple, that you have already learned from Foundation 2, and absolute value inequalities. I think we might be able to finish this section today. That'll be great. Then we catch up. We caught up. Okay, let's continue. So the first problem, question number 15 here, we are looking at an inequality. Because we know it's an inequality because it has one of the inequality symbol. Just let me spend a little time here. Inequality symbol. Okay. So this is the inequality symbol. This one, yes, this one or this one. Technically, this also is an inequality symbol. Not equal to is also inequality symbol, but we do not, you know, have to worry about that. We don't have any inequality with that in it most of the time. Okay. All right. This means less than, right? Or strictly less than. And this means less than or equal to. Less than or equal to, or no more than, or at most. Okay, this symbol as less than or equal to. For example, 2 here and x here. 2 is less than or equal to x, or 2 is no more than x, or 2 is at most x. All right, so that's the meaning of this inequality symbol. Next one is a strictly bigger than. And the last one with the bar under is bigger than or equal to. Or equal to. Also, it could be no less than or at least. For example, in order to pass this course, at least you need to have, this is your score. In order to pass this course, at least your grade needs to be 70. Okay, no less than 70. If 69, you don't pass with a C, you get a D, right? So this symbol means at least or no less than. If we have an expression, if we have something involve one or more of those symbols, then we are looking at an inequality. All right. So this inequality is very simple. It's just a linear inequality. How do we know it's linear? Because when x shows up, it's just by itself. It doesn't have a square or cube or square root or anything. So that makes the inequality linear. So we have negative 11 plus 8x strictly less than 12 plus 13x. As always, I like to separate the inequality as two parts, left side and right side. Okay, I like to do that. And my goal here, I want to isolate the x on the left side. We should always try to isolate the variable x on the left side when we solve an inequality. Okay, for that reason, I'm going to minus 13x from each side. Now I can get rid of 13x from the right. And I'm going to have a negative 11. I'm going to have negative 11 minus 5x. Bring down the inequality symbol, okay? Bring down the inequality symbol. On the right side, we just have 12. So first again, yes, subtracting 13x from each side. And then I want to get rid of negative 11. So I'm going to add 11 to each side. And after that, we would have negative 5x by the sub on the left side. Bring down the inequality symbol. 12 plus 11, 23. Okay, 12 plus 11, 23. Okay, very important. Next step, we want to isolate x, right? In order to isolate x, you want to mute yourself. Okay, so thank you. So suppose, of course, we do not have an equation. Suppose it was an equation. 95x equals 23. Then how do we isolate x? We divide each side by 95, right? So we have x equals negative 23 over 5. Same idea. We want to isolate the x on the left side. So we have to divide each side of the inequality by negative 5. However, there's a very, very important rule. I don't know if you remember, you have learned from Foundation 2. When we solve an inequality, and we need to multiply or divide each side of the inequality by the same negative number, we have to switch the direction of the inequality symbol. Let me know how many of you remember this rule? How many of you remember this rule? Okay, very good. I saw Michael. Okay, Eliza also remember that. Let me repeat it. This is not something new. You have learned that from Foundation 2. When we solve an inequality, and you need to multiply or divide each side of the inequality by the same negative number, we must flip the direction of the inequality symbol. So here we need to divide each side by negative 5, right? Since negative 5 is a negative number, we have to switch the direction of the inequality symbol in the inequality. As you can see, is facing to the right. Now it's facing to the left, right? Yeah. Maybe you remember the teacher in middle school, they described the inequality symbol like a alligator mouth, right? And the alligator mouth always chasing the bigger quantity. It's a greedy alligator. Okay, so very important. Don't forget, we need to switch the direction of the inequality symbol. And then cancel that. We have x is bigger than negative 23 over 5. Okay? And then most of the time, the problem asks you to write the solution set of an inequality in the interval notation. So this is how do you do that? How do you proceed from here? So explain our solutions. When we solve an inequality, majority of the time, the solution is not just one. It's not just one solution. You probably have infinitely many solutions. Your solution probably is an interval on the real number line, right? So here, all the real numbers that are bigger than negative 23 over 5 are solutions. So the reason I want you to, as a beginner, if you are not very familiar with this part, you write this down, then you have an idea. You can see the picture. What are the solutions? The solutions are not just unique. It has many, infinitely many. Any real numbers, as long as the real number is bigger than negative 23 over 5, those real numbers are all solutions of the inequality. Okay, so we can draw the graph on a real number line. Let's say this is 0. Suppose this is negative 23 over 5. Any number strictly bigger than. So we're going to have a circle here. because strictly bigger than, right? So we have a circle here. And all the real numbers strictly bigger than that. So on the real number line, I shaded the region that cover all the solutions of the inequality. And that is one piece, right? On the real number line, that is one interval. And that interval has a left end point, negative 23/5, left end point, comma, right end point, you see the arrowhead is infinity. So you have a left end point, right end point, use a comma to separate them. We always use parentheses to frame the inequality. To frame the infinity. Sorry about that. And for the left end point, the reason we also use parentheses is because we have a circle here. Because the inequality symbol does not have the bar under. So we use parentheses to indicate negative 23/5. That number itself is not a solution. In the case we have this, in the case, of course, not this problem. In the case we have bigger than or equal to, then you need a bracket to indicate the left end point is a solution. All right, so this, again, this is not new. Just some review solving a linear inequality. Important thing, do not forget, when you multiply or divide an inequality by the same negative number, has to be negative number, you must switch the direction of the inequality symbol. If you multiply or divide by a positive number, you don't have to, okay? All right, next, we're going to talk about how do we solve a compound inequality. A compound inequality contains more than one inequality symbols or more than two parts. Yeah, we're gonna look at the two types. This is the first type. -8 is less than 4x plus 9 and less than or equal to 3. So this is a compound because it has three parts. If you wanna, I don't know if you like this. I like this. I separate the inequality into parts. Since this is a compound inequality, I have three parts in it. All right. I call them, this is called the left side. This is the middle part. This is the right side. So this is a compound inequality with the three parts in it, right? In the middle, we have 4x plus 9. It is bigger than -8 and is less than or equal to 3. Compound inequality. When we have a compound inequality look like that, our goal here is to isolate variable x in the middle. Isolate x in the middle. Isolate x in the middle. This rule always works because the compound inequality we encounter are very simple, you know. Of course, they are more complicated, but we don't worry about them. For the compound inequality we would ever encounter, use this rule. The goal is to isolate x in the middle. For that reason, we're gonna start to peel the onion again, right? The idea is the same. We're gonna peel the onion. 4x plus 9, we're gonna get rid of the 9 first. So we're going to apply the same treatment to all the three parts. Left side, right side, middle. We must treat all the three parts the same. Okay, we need to minus 9 from the middle because we want to isolate x, right? We want to get rid of 9. But we have to do the same thing to the left and to the right. After that, let's see what we have. In the middle, we have 4x. We just have 4x because 9 and -9 cancel each other, right? And bring down the inequality symbol. On the right, 3 minus 9, -6. On the left, -8 minus 9, -17. Not bad, right? I believe you can do that. So minus 9 from all the three parts. Minus 9 from the left side, we got a -17. Minus 9 from the middle, we have 4x. Minus 9 from the right, we have -6. Okay, very close to isolating x in the middle. Now we're going to get rid of the 4. How do we get rid of the 4? We are going to divide by 4, right? Divided by 4. And we cannot just do that in the middle. We have to do the same thing to all the 3 parts. So divide by 4 here, divide by 4 here. And bring down the inequality symbol. In the middle now we have x, because 4 over 4 is 1. On the right we have -6 over 4, that is -3 halves. On the left we have -17 over 4. And that's it. Once we have x isolated in the middle, we have the solutions. The solutions are all the real numbers that bigger than -17 over 4 and less than or equal to -3 halves. Okay, in other words, the solutions are real numbers in between -17 over 4 and -3 over 2, but exclude -17 over 4, include -3 over 2. On the real number line, let's say this is a 0, and this is a -3 over 2, and this is a -17 over 4. And to graph the solution set, remember in the middle between the 2 numbers, -17 over 4 is excluded because this inequality symbol does not have the bar in it underneath. So we have a circle here. But -3 over 2 is included because this inequality symbol has a bar under it. So we have a solid dot here. All right. For that reason, the interval that represents the solution set is going to be a left open, right closed interval. This is how do we do that. So to write the solution set as an interval, left and a point, that's where the red piece starts from, comma, right and a point, 93 over 2. Close, open. Anybody understand why we use parentheses to frame the left and the point, but use a bracket to frame the right and the point? Anybody understand that part?
When it's a filled circle, it's a bracket.
When the circle is a parentheses.
No, like when it's the filled circle. Like filled circle's a bracket.
Okay, yes, solid dot, exactly. So when the inequality symbol has a bar underneath, bracket, without a bar underneath, parentheses. Okay, those details matter. All right, let's move to the next question, another type of compound inequality. Yeah, earlier this compound inequality actually, what is compound inequality? Actually means if we want to separate, it's actually 4x plus 9 bigger than -8 and 4x plus 9 no more than 3. So the logic connective is and. That's the reason we can combine them together like this, have 3 parts. But next one, we also have and, but we cannot combine them together like this one, right? Yeah, we would have to solve them separately. We have to solve them separately. So this common inequality is 4x plus 5 bigger than or equal to -35. That's the first part of the compound inequality, right? Yeah, let's do that first. Let's solve that first. This is a simple linear inequality. We need to isolate x on the left side. To do that, -5 from each side, cancel. And we have 4x is bigger than or equal to -35 minus 5, -40. And then divide by 4, cancel. We have x is bigger than or equal to -10. 40 over 4 is 10. Okay, so this part, we solved it. We got x is bigger than or equal to -10. Bring down the logical connective and, very important. Now let's do the second one. The second one is 4x minus 32 less than or equal to 0. Okay, let's solve this inequality. We're going to isolate the x on the left side. We add 32 to both sides. Cancel. And we have 4x is less than or equal to 32. And then divided by 4. Cancel. And we have x is less than or equal to 8. So here we have x. Yeah, this inequality, we just solved it. We got x is less than or equal to 8. All right. X is bigger than or equal to -10, and x is less than or equal to 8. It's good enough for us to graph the solution, the two solution sets on a real number line. The graphing is very important. So the first part, the solution is bigger than or equal to -10. Where's -10? -10, oh, it's right here. Bigger than or equal to, bigger than or equal to. So we're gonna have the -10 solid dot, right? Not the circles, fit in the circle. Bigger than or equal to -10, so we're gonna go to the right. All right, all the way to infinity. So the red color is the graph of the solution set of the first part. And the second part, I need to use a different color. Let's try. How about this bright blue, maybe? Okay. And the second part is less than or equal to 8. 8 is right here. Less than or equal to. So we have a dot here, right? And then to the left, less than or equal to. So to the left this time. Go to the left side. All the way to infinity. All right? Okay. The connective here is very, very important. In our problem, in this problem, it is and. But sometimes you might see OR in it. So you're going to process the problem differently. Let's focus on our problem here. So our problem says and. Because it says and, we are going to take the part on the real number line. We are going to take the part that is covered both by the red color and the bright blue color. Okay? Yeah, the region on the real number line have both red color and blue color. That is going to be the solution set of the original compound inequality. So would you be able to see the region covered by both colors is from -10 to +8, close. Would you be able to see it? Is from -10 to 8. And both dots are solid dots, so we have brackets. You see that? Response?
That's what I got.
Okay, perfect. Oh, okay, Eliza says yes, perfect. Okay, now I'm gonna modify the problem, okay? We're done with this problem. But what if you do not have and? It says or. Yeah, in the middle, you do not have A and D, you have OR. What's your solution set? What's your answer? Or means, you know, is inclusive or. I don't know if you have learned anything in logic. What if it's or? The solution set is what? All real. Okay? It's gonna be the region on the real number line covered by either the red color or the blue color or both. As you can see, the whole real number line has colors. Some part has both colors, some part has red only, some part has blue only, but the whole real number line is covered by the colors. So if the middle, the logical connective is not AND, instead is OR, your solution set will be totally different. It's gonna be all real. Is that clear, everybody? Is that clear?
Yes.
Yes.
Perfect. Okay, let's move on. We're going to talk about absolute value inequality. Insert absolute value inequality. So firstly, I'm going to give you 3 basic formulas, and then we're going to practice this process. And the first one, okay, so if you have this, and you should use the rule I'm going to give you to quickly get rid of the absolute value. When we solve an inequality, the idea is also similar with peeling an onion. To get rid of the thing that trap the variable x, right? We want to eventually isolate x. So right away, you translate that as this. Okay? If the star has absolute value strictly less than 7, then the star is bigger than -7 and less than +7. I can help you to understand on a real number line. Suppose we have x absolute value is less than 2. Okay, this is 0, this is 1, this is 2, this is -1, this is -2. Do you see that only this part, only the real numbers in that red region, their absolute values is strictly less than 2. Their distance away from 0 is less than 2, right? And that is x is bigger than -2, less than +2. Hope this can help you to understand that rule or formula better. If you ever seen something in this form, absolute value of star is strictly less than a positive number. Again, I use 7 because I was told 7 is a lucky number in this country. You could use any other whole number or convenient positive number. The important thing is it is a positive. If it's positive, then right away we can rewrite that inequality as put the star in the middle, bigger than -7 and less than +7. I hope this explanation helps you. That's the first one. And what if it has the bar under? What if it's less than or equal to? Then you just adjust here, modify this bar, and that's it, okay? So it fits both. The second one. What if you have absolute value of star is bigger than 7? Then how do you remove the absolute value symbol? You're gonna right away rewrite the inequality as star is bigger than 7, OR. Okay, it's not AND, it's OR. Or star is less than -7. Okay? Yeah, let me explain. For example, we are solving absolute value of x is bigger than 2 on the real number line. This is 0, this is 1, this is 2, this is -1, this is -2. When which number whose absolute value is bigger than 2? The number who is bigger than 2, right? Like 3 or 2.1, those number is far away, distance far away from 0, like more than 2 units away from 0, right? Also, this part, those numbers less than 92, they have absolute values bigger than 2 because they are farther the distance from 0 is bigger than 2, right? Yeah, absolute value is just distance. Hope this helps you to understand the second formula. If you see something similar like that, absolute value of star is bigger than 7, right away, translate that, get rid of the absolute value by writing inequality as star bigger than 7 or star less than -7. What if you have bar under? You just adjust with the bar under. Okay? All right. Number 3. What if you have absolute value less than 0? And what if you have, yeah, I think I have more than just 3 basic inequality. So I'm going to write more, okay? What if you have absolute value less than 97? What if you have absolute value bigger than 97? What if you have absolute values bigger than 0? What if you have those? You know? Or number 7, what if you have absolute value less than or equal to 0? Or absolute value bigger than or equal to 0? So how do you process those problems? Okay, so let's look at number 3. Let's look at number 3. Please remember, keep this in your mind. Absolute value is a distance. Distance cannot be negative. 0 is fine, but can never be negative. So look at number 3. Left side is distance, right side is 0. Number 3 basically telling us the distance is less than 0. Distance is negative. So what do you think? You don't have to solve it. Make a conclusion, no solution. Is that clear, everybody?
Yes.
Okay. Now let's look at number 7. If you have absolute value of something is no more than 0, less than or equal to 0, and what do? Right away, just make the expression inside the absolute value equal 0, because it's not possible to strictly less than 0. Equal 0 is fine. So you're gonna get rid of the absolute value by doing this. Okay, if the absolute value of star is less than or equal to 0, that means the star is equal to 0, because it's not gonna be possible to be less than 0, not possible to be a negative number. And now let's look at number 4. Look at number 4 here. What if you have an inequality that look like this? Absolute value inequality. Left side distance, right side -7. Distance is less than a negative number. What does that tell you? Distance is less than a negative number. Do you have any solutions for that? You understand, I believe, okay? No solution, right, guys? You can raise your hand or, react anyway. Okay, thank you. Thank you, it's Eliza, right? Yeah. Thank you, Eliza. No solution, because absolute value cannot be anything less than a negative number. Only negative numbers less than -7, so no solution. Then we look at number 5. Number 5. What if you have something like number 5? Absolute value of a star strictly bigger than -7. Is bigger than a negative number. What do you think? This one might be a little bit challenging. Yeah, what do you think?
Isn't it no solution again?
It's all real. Yeah, as I said, this one's a little bit challenging. It's all real. because the distance is bigger than -7 is a true statement, no matter what. It's a true statement no matter what. Because the distance has to be either 0 or positive, right? If it's a 0, 0 is bigger than -7, true statement. If it's a positive, the positive number is also bigger than -7, also true statement. So it doesn't matter what x equal to, this inequality is a true statement no matter what. Okay, I need you to tell me if that makes sense. Number
Yeah.
5. Okay, perfect. Yeah. So those are kind of special. Majority of the time is number 1 or number 2. But sometimes you will encounter absolute value inequality like those special, and take time. Do not rush to solve it. Take your time, because sometimes maybe just no solution, maybe just the all real solution, then you don't have to even do any effort, right? What about number 6? Number 6. Left side is distance, right side is 0. This inequality tells us distance is bigger than 0.
Is it all real again?
All real except 0. All real except 0. So the solution set is -infinity 0. Oh, sorry. Actually, not really that. It's gonna be x is not equal to 0. Yeah, all real except the value of x that will make a star be 0. So the equivalent way to express this inequality without the absolute value is star not equal to 0. Anything else is fine. Could it be positive, could be negative, but cannot be 0. Does that make sense? You might not encounter something like that, but you might encounter something like that. Number 8. What about number 8? Number 8 is all real, right? Because distance is either equal to 0 or bigger than 0. Cannot be negative, so it's all real. Yeah, as I said, those are special. Those are special. Use the definition of absolute value. Knowing absolute value is defined as distance. Distance cannot be negative. So sometimes can just save your energy. If it's no solution, just no solution. If it's all real as solution, all real solution. But majority of time, those two types, this one and this one, majority of time, okay? For example, oh, actually we do have number 17. Do you see number 17? Number 17 here. Absolute value of x minus 2 is less than -2. What's the solution? Okay, I can write it down. So look
No
at this
solution
problem.
on that one?
No solution. You are right. Awesome. Perfect. Right? Save our energy. You don't have to solve it or struggle with it. Distance is less than -2. Is telling us the distance is a negative number, which is a contradiction, not possible. So no solution. Done. Right? Okay. Next one. The inequality is, I'm going to use this space. -4, absolute value, x plus 5, close absolute value, plus 4, less than 0. But this one is more complicated compared with the basic form, right? Yeah, because the absolute value is not isolated. We have to isolate it on the left side. Start to peel the onion. I like to do this. Okay. Get rid of 4 first. Get rid of this addition first. So -4 from each side. Peel the onion, peel the skin on the outside. And then we have -4 absolute value x plus 5, close absolute value, less than 0 minus 4, -4, right? Okay. Okay, this part is a little bit challenging, just in case you forget. Keep peeling the onion, peeling the skin. Next layer we're gonna get rid of is -4, right? In order to get rid of -4, I'm going to divide each side by 94. There's anything special we need to do? Is there anything?
Flip the sign.
Perfect. Awesome. Awesome. Very good. Perfect. All right. So cancel 94. And then we have absolute value x plus 5. Now is bigger than. Right side 94 over 94 also equals 1. 1. Okay. So now you have absolute value of x plus 5 bigger than 1. Look at the first two types. Which type? Type 1 or type 2? We have absolute value of x plus 5 bigger than 1.
Number 2.
Yeah, the second one, right? The second one. So how do we rewrite the inequality by removing the absolute value? We're going to rewrite this as whatever inside the absolute value, we have x plus 5 bigger than 1 or x plus 5 less than -1. Okay, that's how we get rid of the layer of the absolute value symbol. Even we have 2, but those 2 are very easy to solve. And the logic connective in between the two inequalities is OR. Okay, so we are doing this one, number 2. Number 2, when it's bigger than 7, yeah, bigger than 7 or less than -7. So here is bigger than 1. So bigger than 1 or less than 91. All right, so keep going, solve the inequality. -5, -5, cancel, so x is bigger than 94. OR, very important, bring it down. And this one, -5, -5, we have x is less than -6. Done. But the problem will require you enter the answer in the interval notation, right? Okay, let's graph it. Let's graph it. This is a 0. This is 1. So this is 91, 92, 93, 94, 95, 96, 97, 98, 99, 90. Okay, that's enough. Good enough. So x is bigger than 94. Bigger than 94. Strictly bigger. So we have a circle here. Indicate 94 is not a solution. For that piece, okay? Not finished yet. Bigger than 94. So to the right, all the way to infinity. So that's the first piece. Second piece, I'm going to use the bright blue color. It works. Is less than 96. 96 is here. Oh, sorry. Messed up a little bit. I mean, supposed to be a circle. Sorry, it's supposed to be a circle, not solid dot. A circle at 96. Indicate 96 is not a solution. Less than 96, so to the left. All right? Okay, so in the middle, the logical connective is OR, or. And what's your solution? What's our solution? So any part, any region on the real number line that is colored. It doesn't matter what color, either red color or blue color or both. We don't have both in this case. Then your answer is supposed to be, your answer is going to be, first piece, the blue piece, 90 infinity to 96, open, open. Union 94 to past infinity, open, open. This is your solution. Is an union of two intervals. Union in logic represents OR. Do you think you can do that? If you see something like this? Response?
Yes.
Perfect. Okay, we're done with the problem, okay? We're done with this problem. Just to play with it. What if? Of course it's not. I'm just saying, what if? Here is not OR. what if is A and D? What if it was A and D? What's your solution set?
Would it be all real but -5?
No. If it was A and D, the solution set is empty. No solutions. Yeah, I want you to see it because it is possible you have something like that. If in the middle is A and D, after we draw the graphs, we should find a region that colored by both red and blue, right? But we don't have. Those two pieces do not overlap. So we do not have any numbers that is bigger than -4 at the same time. A and D means at the same time, right? Less than -6. So no such variable, no solution, empty set, no solution. Do you see it?
Yes.
Yeah. If it's A and D, we look for overlapping part. I need to go back the previous problem. Where is it? Yeah, if it's A and D, the overlapping part, the two colors, that part is the solution. If it's A and D. But if it's OR, any color, as long as it's colored, right? It's not, doesn't have to be common. But if it's A and D, has to be the common region. Very important. Yeah, I think it's pretty interesting, this part. So that's that problem. Okay, perfect. I think we catch up. We finished the problem I plan to cover for section 3.4, solving absolute value inequalities. Section 3.3 is pretty heavy. It has 3 types of equations, and they have different procedures, different strategies to, and also, especially when you solve rational equations, you have to know how to factor polynomials, right? It's pretty challenging. But when it comes to absolute value equations or inequalities, it's okay. I think it's doable. Yeah, you just need to grasp the formulas or the rules I gave you here. All right, hope you are taking notes and then you understand and memorize those things. Do you guys have any questions? How's the exam 1? You guys make a plan for it?
Yeah, I'm taking mine on Thursday.
Sounds good. Thursday. So today is 25th. Yeah.
I'm taking mine on Saturday. Is that fine?
Saturday, not all the TCC testing centers open. In the past, only Southeast opens on Saturday with a different hours. You would need to check the website. Oh, Max. So you take with your high school counselor, right?
Yeah, we're taking it with our high school
Yeah.
counselor.
Then if your high school counselor is okay on Saturday, that's fine.
Okay.
Very good. I did not know that you guys go to school on Saturday. Okay. Anyway, as long as you are proctored, as long as your counselor physically proctored you, I'm fine with that. Very good. That's for today. Feel free to email me with any questions. I'll see you guys on Thursday. Bye-bye.
Okay, see you on Thursday.
See ya.
See ya.
Bye-bye. See ya.